So that now that you guys know how to synthesize alkynes, let's talk about reactions that we can do with them, okay, with these triple bonds. So remember that, at the beginning I said that, you could do these, the reactions that we learned in chapter 8 to double bonds. We could just do them twice to triple bonds because, triple bonds are basic. They have 2 pi bonds, and we were using pi bonds in chapter 8. And so that's what this section is about. So this is about addition reactions of alkynes, okay? So alkynes, they have those 2 pi bonds. So you can basically add up to 2 molecules across that triple bond. So an example, our generic reaction. So let's say we had this alkyne here. If we were to, react, 1 molecule of AB across that double bond, we can add 1 molecule of AB, or across the triple bond, we can add 1 molecule of AB, and we get rid of one of those pi bonds, but we do have a second pi bond. And so that pi bond can attack our electrophile again, and we can add another molecule of AB across that this now double bond to form an alkane, and with whatever AB was. In chapter 8 we use HBr, HCl. We used H2. We use several different lots of different reagents to add across a double bond. And so now we're going to start to go through some of those reactions and how they would apply to triple bonds. Okay, a lot of them are the same, and you just have to do it twice. Okay, so our first reaction, let's use the catalytic hydrogenation of alkynes. So remember, that's using the palladium on carbon and H2 gas. So catalytic hydrogenation to alkynes. Okay, so if you were to have that generic alkyne and you react it with 2 equivalents of H2 gas, and you use a catalyst of palladium on carbon, it's just going to add 2 molecules of hydrogen gas across that double bond, or across that triple bond. So one is going to turn it into a double bond. The second one, it's going to keep going and turn it into a single bond. So we are going to get 2 equivalents of H2 gas added across that triple bond to form a single bond, an alkane. So this is one way that we can take an alkyne and turn it into an alkane, okay? But let's say you wanted to stop at, at the alkene, okay? So if you use these conditions, it's just going to go all the way to an alkane. But let's say you wanted to stop at the double bond. So if you wanted to stop at the double bond, we have to throw in kind of like a poison to make sure that this catalyst is not as reactive, okay? In order to make it only do 1 hydrogenation and make it stop at the double bond. And so that's what Lindlar's catalyst is. And so that's our next reaction. So I'll label this as subsection B. So this is called a partial hydrogenation, or partial catalytic hydrogenation. And this is going to form a cis alkene. Because remember, when we used palladium on carbon before, That was a syn addition, okay? So it's still going to be a syn addition. The two hydrogens are going to get added to the same side. So if you were to have our alkyne, and you react it again with H2 gas, palladium on carbon, but now we want to throw in that poison to make sure it stops at the alkene. And so that's just called, we call it Lindlar's catalyst. And it's just basically a poison, and it's just going to make it, or that's kind of how I remembered it as. It's going to make it a poison, and it's just going to, make it stop reacting. And so you're going to get a cis double bond as your final product. So cis, same side. So you have your two hydrogens that just got added with using the Lindlar's catalyst. So I'll say Lindlar's catalyst is like a poison. And can only add H2 via syn addition one time. And that leads to the cis alkene. Okay? So, let's say you didn't want the cis alkene from a triple bond. Let's say you wanted the trans alkene from the triple bond. Well, organic chemists have got your back because they wanted that too. So that's going to be our next reaction. And this is just called a metal ammonia reduction to a trans alkene. So what that would look like if we start off with our generic reaction is if we were to react this, it's using sodium metal, okay? So that's sodium metal, not a sodium ion. Sodium metal with ammonia, and that is going to give us a trans double bond. And so H2 is now going to add anti in these conditions. So H2 adds anti to alkyne, and that gives you a trans alkene. Okay. And so all these reactions, these three reactions here, these are not reactions that you guys have to know the mechanisms of, because, they're either only partially understood or a little too complicated for our, current, knowledge. So don't worry about the mechanisms, but we should remember what these products and these reagents or what the products these reagents make, okay? So we get an alkane from a triple bond if we don't add a poison. If we add a poison, it only stops at the cis alkene. And if we start a new reaction, sodium metal with ammonia gas, that's going to give us our trans double bond, okay? So that's those three reactions there. Now let's move on to adding halogens across the double bond, okay? So again, or not double bond, the triple bond. Again, this is something similar we did in chapter 8. So addition of halogens across triple bonds. So if we start off with our triple bond and our two different R groups, if we add one equivalent of H2, or not H2, one equivalent of, our halogen, either Br2, Cl2, I2, you guys get the idea. It is going to add both syn and anti, It follows a very similar mechanism as that we did in the in chapter 8. So it goes through like that brominium or chlorinium ion looking thing. But since it's not these are trigonal planar intermediates, it's not going to have a preference to either, syn or anti-addition. So it does both syn and anti-addition. And this is going to lead to both cis and trans double bonds. Okay, so that's if we have only one equivalent, okay, of Br2, Cl2, X2, or halogen, okay? If we were to have two equivalents, it's going to keep on reacting. So if we were to have our triple bond and have two equivalents of, our halogen, that's going to add twice. So we're going to get we're just going to halogenate everything, basically. Okay, so that's going to give us lots of halogens on our the two carbons that were part of the triple bond. So an example of this would be, let's say we have this triple bond here, and we react it with two equivalents of Cl2. So that is going to chlorinate this carbon here and this carbon here. And so we're going to get lots of chlorines on those two carbons, like so. Okay? Remember we have one hydrogen coming off of that this terminal alkyne. So that hydrogen is still right there, but we need to add two chlorines to each of those carbons that were part of the triple bond and get rid of any pi bonds there.